Yeah, so it's been a while since we had a meeting. So I thought like we could just use today to catch up and see what people are up to, where support is needed, what things need to be polished or cleaned or...
Now that you're free.
Yes, exactly, exactly. The weight is off for now, so it feels really good.
Back to the fun stuff.
Yeah. I did not let myself really do much coding. There's so many, I mean, I only did the bare bones of what needed to get done.
Plots and whatnot.
Yeah. Well, and there's a few developments that were needed, like, because a lot of the stuff looks at the physics. So in the time domain codes, we can now view charges and things like that, which is kind of cool. So yeah, it's kind of neat to actually like run the charges experiment and like watch what the charges are doing. So that will come in. And then there's some other stuff like, I was fiddling around a little bit with directives. I've got some ideas in there about like, we can start setting like directories and things like that. Because if you run, so I was working in one notebook where I ran 4 different inversions, and it's like super annoying if they all end up in your current working directory. Mm-hmm. So like you just want to be able to be like, this inversion goes here, this inversion goes there. And so I have a sketch of that started.
Okay.
Which is kind of handy.
Actually, the whole saving thing, we should review it because we're doing things. There's a little bit of pickling. There's a bit of saving to file, and people use it.
Yeah.
I use it, and every time I need to hack something because it's not exactly doing what we want.
Yeah. I think we should take a look and sort of standardize some of that stuff. I wanted to look into Xarray potentially for saving fields objects. Because fields objects are pretty heavy, right? Or not even objects, just a fields array. Like if you solve, because if you got a big enough mesh and you solve for the electric field everywhere in it through time, and you save that, it's a big file. Mm-hmm. And loading that takes a really long time. Whereas I think Xarray is smarter and only accesses like exactly the segment of memory that you need to do your given computation. So that's something I think we should fiddle with.
Xarray is good for matrices, right?
Yeah.
Okay.
Yeah. There's one called Parquet that's good for data frames, for big data frames. So it's sort of like the equivalent to saving a pandas object. Xarray is equivalent to saving like a NumPy.
Yeah.
So those are things to look into. That's less of a priority. I think saving like the basics of saving, I think we should seriously look at. I like the way that we can save and load the mesh, for example. I think that's pretty simple. Because you can actually recreate the entire object like very trivially.
Yeah.
So I think that's what we want to try and do throughout.
But for raster data, when you have like big entries, big number of entries, it's not as simple as packing it. Right? You need to store it somehow.
Right. But I think like starting to think of saving the JSON as the main thing that we save. Yeah. And then if there's a giant array in there, then we have a pointer to the file.
Makes sense.
Yeah. So I think that like the JSON is sort of our high level thing that we save. And then if we need to get fancier underneath, then we can. But
what about H5? Do you think it's a bad idea to go down that road, or because it's compressed?
Well, like the JSON that we're creating it's pretty light.
No, it is.
Yeah.
But in terms of when we're going to save those XArrays, they're just going to be stored to file. Like what's going to be the?
It's stored as Xarray. And so what's interesting, and this is something I learned and want to get a better handle on, is H5 is actually not necessarily the best cloud storage solution. I mean, for the size of things that we're working with, it's not that big of a deal.
Okay.
But H5 is like starting to taper off a bit. They've gone quite closed source, and so a lot of the open source community is sort of like shifting away from that a bit.
Okay.
NetCDF is one that people are excited about because they do a really good job of making sure that no matter which version of NetCDF you saved your stuff as, you can always rate it in. So that's something to look into. But I think in a lot of ways, like the simplest we can keep it, and then if we start running into memory issues, then we tackle them.
Yeah. Totally.
Yeah. Yeah, so those are some of the things. The simulation class, and that will be a lot of the saving stuff, I think, will come into that. Because I think we should be able to save like the state of a forward simulation object, for example. So that if you, like one of the things that I did for a lot of my thesis work was I wanted to be able to like interactively create the simulation parameters, so set up the model, the mesh, my frequencies, all that sort of stuff in the notebook, because then you can do all the error checking, make sure your padding is far enough. But then I saved a like simulation.py that I taped over to the cluster. And so I think we want to try and make that very easy for people to do.
And yeah, in terms of like giving away scripts to people to be able to run, it's going to be way better if they're packaged, right?
Yeah.
It's easier to maintain.
Yeah.
Those notebooks are fun, but man, they're hard to maintain.
Yeah. 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 So those are some of that's like what I'm going to be up to. But what are you guys up to these days?
Just went back recently to my code, actually just Friday and yesterday after a lot of GIF tool and TA hours. And yeah, no, I mean, and it's good. Like basically, I'm able to run book pronoun, EM1D parallelized, petrophysically constrained.
Okay.
So
right on.
It just like we can
do just a hookup.
You can just hook that up, and it works actually well. Considering that we have no petrophysical data for book pronoun, it's able, like the algorithm is actually capable of picking values that are reasonable and then stick to that. So
it's just clustering. It's just clustering based on number of families.
Yeah, like the only thing I set is find me 3 clusters.
Okay.
That's super cool.
Yeah. So it finds like the top, the bottom, whatever.
Yeah, and then like kind of like
the water
out of range.
Okay.
So you have like also an idea of like, oh, that's probably how deep I can see.
Right on. Are you gonna show this? You're gonna show this to sponsors, right? At sponsor meeting.
We could. Yeah.
Just slides.
Yeah.
That'd
like I mean. Yeah. That's so it's easy to run, and then like as I said, like, one of the only parameter is the number of clusters. So I run it with 2 and 3 clusters, and results are similar, but you have just a little difference. And then like that's where like if you have geological information like knowledge of the field, that's where that can help for the interpretation and choosing the right parameters.
And you're parallelized, right? You're using the parallel switch.
Yeah.
Sweet.
Yeah, and the number of iterations is still very reasonable.
Is it slower to do the? Is it much slower to do the clustering?
For this particular example, I think it doubles the number of iterations, so it went from 5 to 10.
Okay.
It's fine.
Yeah.
So
on the parallel note too, I was also like fiddling with Dask when I was running some simulations. It's actually pretty easy. So I think that like while doing the simulation refactor, I'm gonna look for opportunities to just stick it in.
Yeah.
And it's nice because what you can do is you can do it as just like decorators on functions actually. So it really doesn't mess with your code readability too much, which is important. And so that's pretty slick. So hopefully we can get that up and running pretty quickly. I was doing a bit of reading. There's some cool things that you can do with like the cloud infrastructure, and at some point it would be fun to look at how we could potentially apply some of those strategies to our cluster. But that I think is a whole can of worms that I don't know enough about.
You need to update the OS and all that stuff.
It has been updated.
Okay.
Yeah. Yeah, because it got so old that Git didn't work anymore.
Okay.
And then I emailed Roman and I was like,
none
of us can work if we don't have Git. So it's up to me.
Okay.
Yeah.
nice.
Yeah, it's pretty.
Yeah.
Install all the latest packages on without destroying things now.
Yeah. It's exciting.
Oh yeah, so we could slave it to do like. Can you set up a Jupyter Lab?
So the thing,
Because it's idling most of the time.
I know, I know. So I think we probably could. We would need, there's a few things that we need. The first thing I would actually want to see is us set up Kubernetes on there. And so what that lets you do is actually configure sort of the hardware as whatever you want.
It's like a user, that's the user throttle, right? You can like pick resources on.
Yeah, I mean, but so we have like fixed resources on the cluster, but it's actually a layer that then just allocates resources how you want them allocated, if that makes sense. I don't know if that's something that we can, I'm sure it is something we can do in our cluster.
Because it's such a pain in the ass. So like we never had like management in terms of like resources, like who runs where.
Yeah.
And then you always need to like look at all the nodes, like, man, only if we could have like a top layer, that would be sweet.
Yeah, yeah. So maybe in a year's time when I know more about you.
Okay.
That can be a side project.
Yeah, totally.
Yeah. Because I mean, setting it up on Google was actually, I was surprised at how easy that was. We did it like start to finish. I had it hooked up to my personal website in 4 hours.
Mm-hmm.
I had a very vanilla version, but it was working, which is it's cool. So, yeah, I think that would be super powerful if we had that.
Absolutely.
Mhm. So, what are you? You're on toolkit stuff. And
Yeah, toolkit stuff. I really like doing the seeing how Lewis. Look at his name. Atiando.
Oh, Leo.
Leo. How Leo set up his library. I guess this is the new norm or whatever, but we should definitely do that, right? The installation is super easy. Instead of having notebooks, everything is a script converted to a notebooks on the fly.
Yeah.
It's clean, you know?
Well, that's what we do with the SimPEG docs.
Yeah, not all of them. Yeah, all the examples and everything. Right? We should try to do that. It's pretty good.
Yeah.
I was reviewing the rotation, the mesh rotation gradients. So I found a way to be able to do it on both on a tree and tensor.
Nice.
Using the same column. So that's that was a pretty nice breakthrough for me. I'll try to create a pull request at some point. PR is still, I found some bugs running my own stuff, so I'll need to push a few more now.
Okay.
And that's pretty much it. Mikey?
I haven't been doing too much as far as research or something recently, just mostly TA stuff and trying to write. So I think here at some point, I was talking to Soggy, he was saying that to do like a grounded source EM experiment, we were going to need to add a few things. He was interested in looking at that when I get to it. So that'll be one thing that we need to probably look at.
Well, let's keep it in the loop because all my thesis stuff was grounded source. So there shouldn't be, there's a bit with respect to source definitions that we can make easier. But if there's stuff that you need to set up and run right away, we can do that.
Yeah, it's probably not going to happen. Doesn't necessarily need to happen in the next month or anything.
Yeah.
Eventually, I'm going to need to run some examples.
Yeah.
Hopefully.
Well, I was in touch with Dieter yesterday, and he's interested in just sort of seeing the marine CSEM capability of SimPEG, 3D specifically. So I'm going to set up a small example. Like I told him, we're not scaling to huge 3D problems, but if you're interested in helping make that happen, like we actually have all the infrastructure for 3D code because he's sort of charged with helping generate some 3D codes. And so if he doesn't have to like rewrite most of the things, if he can plug right in, that would be cool.
Mm-hmm.
So I'm gonna work on an example for that and might send that around.
Yeah.
Which is fun. Yeah. The other thing, I guess there's two other things to bring up. One, I think we should somewhere, I can maybe just even start a Google Doc of just like papers that we want to write as a group, like things that we should keep track of. So I think there's one for the combo objective function, and I think it's much more powerful actually like once your stuff is out, is because because the combo objective function like isn't necessarily novel on its own, but if that is then a review paper of other papers that are out there, talking about different joint inversion styles and how we achieve that all using one framework. I think that's actually like a super cool paper. So it's one for the docket. We don't need to tackle it right away, but it's nice to just.
But it's definitely this one. Like it's, like I will admit when you first presented it, I was like very maybe early in SimPEG era. I was like not seeing the whole point at the beginning, but now that I use it, it's so powerful.
That's cool. That's really cool.
So good job on that one. Yeah, deserve at least a communication.
Yeah, so that would be a cool one to do. I think, I mean, we drafted one for discretize that's like mostly done. So that should get done at some point. But if there's other ideas that you guys have of just like things that would be interesting to pursue together that are like related to your research, but maybe you don't want to do all the examples or whatever, let's keep that on the radar. So that's, and then the other thing, and this will probably be something we organize when Soggy is back, but I think that we should put a meeting on the books where we all are in the same city once Soggy and I leave, so maybe like 6 months afterwards or something like that. Because I think it's really important to have FaceTime and have like 3 days where we're working together on stuff that's relevant and just yeah, make sure that we like start sort of an annual SimPEG.
Conf.
Yeah, even just us for the first while. But one of the things that I would like to do if we do that is try and seek out just minimal sponsorship. Like, I don't think we need much. Nobody's gonna pay for our flights or anything. But if we get somebody sponsoring lunches or something like that, we just to start getting buy-in.
Well, we could turn it into a mini conference for sure. Have some talks.
Yeah.
If the plan rolls the way it is, we'll be using SimPEG within the sponsors more heavily. So eventually people will be running the codes and have some things to contribute back. You know? Yeah.
Well, and the other thing that we could do, and this might be more beneficial at that point, is to do a mix, and so do like a day of tutorials and then a dev day or something like that. 2 dev days or whatever.
Totally.
Yeah. So just give some thought to like how you would like to see that happen. But I think it's important that we actually create something formal that like we can expense flights to so that we can all meet up and
It's not a bad idea to turn it into a training. You know, there's people want sometimes just to have pure Python training. We have our you know, we could offer it and then use the same occasion before or after to meet up.
Yeah, so let's mull on that. But
for sure.
I think that'd be good. Always nice to have a good excuse to come back to Vancouver.
Keep the crew.
Yes, exactly.
Is Vancouver the center? I guess it started here. Doesn't have to be here.
I think in a lot of ways it
makes sense.
It makes sense, and I also think that industry-wise, our best bet is starting in Vancouver in a lot of ways, or at least sort of centered from Vancouver. Just because we already have all the connections here. So
critical mass.
Yeah. We'll see where things go. Well, anything else you guys want to go over? PRs, anything? No, we can wrap up early, and I won't be here next Tuesday because it's Thanksgiving. I'm going back to Calgary to veg. So we can either plan for, well, the sponsors meeting is that week too, so that's
And the week after is SCG.
It's SCG.
Right. I'm like, if you guys do have, if there's stuff we want to briefly go over, I'm happy to call in remotely.
I don't think it's going to be a help. We'll be the totally choose to
Yeah, that's fair.
next up.
Sounds good.
See you in 2 weeks.
Yeah.
Congratulations to the third woman to win the Nobel Prize of Physics.
Oh, no, not gonna happen, but that's all right.
Well, you could be the fourth one if you want to.
Who's the third? Yeah.
I just got announced yesterday. Yeah, Canadian woman.
Oh, wow.
She contributed to the laser PCA. It's like the smallest laser pulse, whatever, chirp.
Oh, okay.
That's how they isolate viruses and bacteria, and they do laser operations. It's with that technology.
That's
shared it with
Oh, she's Canadian.
Twitter guy.
That's
Yeah.
awesome.
Here's the bar. Here's the bar.
We'll do what we can.